Before we move on to a new section, let's just go over those forms of a linear equation that we've been talking about. We had our standard form, our ax plus by equals c, and we used that form to find our x and y intercepts. We then spent some time talking about slope-intercept form, which was another quick graph method, because if we had identified our slope and y-intercept, we could start graphing on the y-intercept, find a second point, and we could graph that line as well. And that's also called our function form. And then the last one that we spent a little time, I believe, last week on was the point slope form. Y minus y1 equals the slope m times x minus x1. Let's spend a little time reviewing that last type before we move on to our inequalities. The point slope form, once again, is written here. If we give you the information of slope and our x1 and y1, that's what this is here, it's a point on that line, x1, y1, all we need to do is replace those into the form. Y minus 7 equals negative 3 times x minus 4. And that's all there is to this, to write it in that point slope form. We showed the last time that we can transform this back into slope intercept form and even standard form. But for the time being, we're just going to put it into the equation. Second one, again, if this is your y1, your x1, y1, you're going to replace that into the model, and we're going to get y minus 3 equals 5 times x minus 6, replacing the x, the y, and the m. Last one, y minus a negative 4, here's where we talked about that negative sign, 2 times x minus 8. When the coordinate is a negative, we have to simplify that, and that just becomes the positive. And like I said, we could distribute and we could rewrite this by distribution and combining like terms over, or moving terms over. We could write this into slope-intercept form. But for now, I'm happy if we could just see how to replace that into the model. So that's one thing I wanted to cover today. Then I did want to move on to our next topic, which is linear inequalities in two variables. A linear inequality in two variables, x and y, is an inequality that can be written in one of the following four forms. I have the ax plus by is less than c, or less than or equal to c, greater than to c, and greater than or equal to c. So these are the four forms. And we're going to start off, before we get to the graphing, is just looking at possible solutions. Well, an ordered pair x and y is a solution of an inequality, a linear inequality in two variables, if the inequality is true when these values of x and y are replaced into it. So here we're going to test out negative 6 and 2. Here's my x and y. Here is my linear inequality in two variables. I see that y will be replaced with 2. X will be replaced with negative 6. And then we'll subtract 9. So again, let's see how we go about simplifying to test out this possible solution. We've got negative 18 minus 9. Add the opposite will give me negative 27. Is 2 greater than or equal to negative 27? The answer to that is yes. So this is a true statement. So that tells me that negative 6 and 2, this ordered pair, is a solution. When we graph it, I'll go into more details. Let's look at a couple more examples. Let's take the same inequality and test out 3 different possible ordered pairs as possible solutions. 2x plus 3y equals 5. If x were equal to 0 and y were equal to 1, will that be a true statement? I have 2 times 0 plus 3 times 1, is that greater than or equal to 5? Well, 0 plus 3 is 3, and 3 is not greater than or equal to 5, so this is a false statement. So this is not a solution. Try the next one. What are we doing? Replacing our x with 4 and our y with -1, and we're going to use that same inequality for this one as well. I have 2 times 4 plus 3 times a -1, and I'm wondering if that, when simplified, is greater than or equal to 5. Well, I have 8 plus a -3, and 8 plus -3 is 5. Is 5 greater than or equal to 5? That is a true statement because it is equal to. So this is a solution. Remember, when we're dealing with x's and y's, we need an ordered pair as a solution, not just a value of one variable. And we'll try one more. We have 2 times 2 plus 3 times 1. Is that greater than or equal to 5? I have 4 plus 3, and 4 plus 3 is 7. 7 is greater than or equal to 5. Another true statement here. This is a solution. So all we're doing is substitution or replacement of values into an inequality, simplifying and looking to see if it makes a true statement. We have just a couple here, and I think I'll save these to go over in class. We'll try these 3, and basically that's all we need to do is substitute to see if it creates a true statement. If the statement is true, we have a solution.